Welcome back. To finish up graphing parabolas, we want to again talk about two of their parts. We've already seen how you can find the vertex point and the axis of symmetry algebraically without even having to graph the parabola. Well, that's also true with the x-intercepts and y-intercepts. I can ask you to tell me the location of the x-intercepts and y-intercepts of a parabola without having to go to graph paper and graph. So let's talk about how you algebraically find the location of the x and y-intercepts. So we have to think about the definition. An x-intercept means where the parabola would touch the x-axis. And if you're a point on the x-axis, that means you're never moving up or down. So if you're a point on the x-axis, if you're an x-intercept, your y value will always be 0. And we saw that a minute ago. In the previous video, our x-intercepts were 2, 0. So the y value was 0. So that's how we're going to algebraically find an x-intercept. To find an x-intercept, you take your equation and substitute for y, 0, and then solve it for x. Vice versa. If I want to know where the y-intercept is located on a parabola, well, think about it. If you're a point and you're on the y-axis, you did not move right or left. So that means if you did not move right or left, your x value is 0. And we saw that again in the previous video. Our y-intercept was 0, -4. The x value was 0. So that's your rule. To find a y-intercept algebraically, you let the x value be 0, you substitute that in, and then you'll solve for y. So I can ask you to give me the location of all the parts of a parabola without actually having to look at the picture, the graph. You could find all those parts algebraically. So let's try this. If you look at the PowerPoint, your quadratic equation is y equals 2x squared plus x minus 3. We know that's a quadratic equation. It's degree 2. Therefore, we know if we draw it, it's a picture of a parabola. I don't want you to draw it. I just want to know where's the y-intercept located, where's the x-intercept located. When we're talking about a parabola, we always do the y-intercept first because every parabola has one y-intercept. You will always have an ordered pair for that. So the rule is to find y, you replace x with 0. So if you look, I substituted where there's an x, 0. So now my equation says y equals 2 times 0 squared plus 0 minus 3. Then I followed order of operations. I squared first. 0 squared is 0. I multiplied it by 2. I still got 0. And then I added my 3 constants. 0 plus 0 minus 3 would be -3. The problem is, if they ask you the location of the y-intercept and you just say -3, you are technically wrong. A y-intercept is a point. A point must be named as an ordered pair with an x value and a y value. The x value is 0 because that's what you substituted in. The y value is -3. So the location of the y-intercept is 0, -3. Everybody's good? And that's always the first intercept we find because every parabola has a y-intercept. Now, we talked about the x-intercept. If you're on the x-axis, your y value is going to be 0. So that's your rule. If I ask you to find the x-intercept algebraically, you substitute into your equation y, replace it with 0. Now, let's go down and do this. Here's our equation. Y equals 2x squared plus x minus 3. So now I'm asking you to find the x-intercept, which means replace y with 0. When I do that, I get the equation 0 equals 2x squared plus x minus 3. Here's the problem, ladies and gentlemen. Now you have to use information you've already learned in previous modules. I'm asking you to solve that equation for x. When I ask you to solve for x, I mean to get x by itself. Well, right now, it's quadratic. It's an x squared. You learned 3 different ways to solve a quadratic equation. You learned you could factor it, square root it, or use the quadratic formula. Now, I'm going to tell you very honestly, the last resort is using the quadratic formula. In most algebra classes, we will want to go with the quick approach. And the quick approach is this quadratic equation ready to factor, or do we have to do the square root method? Well, if you know your steps, factoring means your equation has to be set equal to 0. Well, that step is already done. Our equation equals 0. So we're going to factor it. It's got 3 terms, a trinomial. The coefficient's 2, which means it's a difficult trinomial. So you could either use the backwards FOIL method or you could use the AC grouping method. Okay, when you factor that trinomial, you will get 2x plus 3 times x minus 1. We discussed this. When you factor quadratic, you make 2 linear equations. You take both linear equations, you set them equal to 0, and you solve them. So one solution for x is 1. The other solution for x is the improper fraction, 3 over 2, 3/2, or you can convert that to the terminating decimal, 1 5/10. Now, again, here's the problem. If I ask you the location of the x-intercepts, you just can't write x is 1 and x is 3/2. You have to write them as ordered pairs. So each of these, there's 2 x-intercepts. You have 2 answers for x. The y values for both of these are 0 because that's what you subbed in. So we would say our x-intercepts are 3/2, 0, 1, 0. Or if you didn't want to use 3/2, you could use the 1 5/10, 0, 1, 0. So now you know you could find all parts of the parabola algebraically and locate them without having to look at the graph. Let's go to the whiteboard.